Welcome back. And from this section, we will see how we can execute the GCP resources using Terraform. But before this, first let's see a comparison between the Terraform and Google Deployment Manager. Google Deployment Manager is a deployment tool like Terraform, but that is specific to GCP. So we will see what is the difference between Terraform and Google Deployment Manager so that we can choose Terraform over Google Deployment Manager for the GCP resource deployment. So very first difference is Terraform is a widely used public cloud tool. On the other hand, the Google Deployment Manager is also a IAC tool, but that is only limited to the GCP. So as we already aware that using the Terraform, you can spin up the resources in any cloud, even the public or private cloud. But the Google Deployment Manager is a GCP native service, which you can only use with the GCP. You cannot use the Google Deployment Manager with any other cloud. So if you want to create the hybrid deployment, you want to create the multi-cloud deployment, then that is not possible with the Google Deployment Manager. Second, as I told you that Terraform is Second, as I told you that using the Terraform, you can deploy the deployment on multiple clouds. So with the Terraform, it is possible to create the multi-cloud deployment or the hybrid cloud deployment where few of your resources are deployed on cloud A, few of the resources are deployed on cloud B, and few other resources are deployed on cloud C. It is also possible that you can create the different configuration file for the primary site or for the disaster recovery site. But on the other hand, if we are using the deployment manager, then deployment manager only and only limited to the GCP resources. And there are many fundamental differences as well, which make the Terraform more usable, more useful as compared to the Google Deployment Manager. Another high level difference is that Terraform use the HCL. HCL means HashiCorp Configuration Language, and you will get a very handy document on HCL for each cloud provider, either GCP, Azure, AWS, or Oracle Cloud. But the Google Deployment Manager use two kind of formatting. First is a YAML formatting, and second is Jinja formatting. Within the Jinja formatting, you can use Python short of code, but YAML formatting is a complete YAML based formatting which is used to create the infrastructure file for Google Deployment Manager. In terms of the usability, the HashiCorp configuration language documentation is quite rich as compared to the deployment manager YAMLs or Jinja formatting document, so that user can easily use the HCL to create the different resources as compared to the YAML formatting configuration in Google Deployment Manager. As we already mentioned that Terraform support almost all major cloud services, but the deployment manager only support the Google Cloud. So the infrastructure as a code file which you created in the deployment manager, they are not useful if you want to create the similar kind of resources out of the GCP. The another difference is about the user interface and the user usability. So we can say that the deployment manager is in the initial phase. Terraform is a complete tool which is being used 90%. Terraform is a completely deployment automation tool or infrastructure as a tool which is the most popular and first option while we choose the automation as a code tool. On the other hand, the deployment manager is not that mature as compared to the Terraform, and you will not get any kind of logging features in the deployment manager. So once you will start deploying the machine using the deployment manager, you are not able to store the logs anywhere that what is happening behind the deployment manager. Apart from the logging, within the Terraform, you can use the Ansible to execute some pre-deployment script or some post-deployment script. But with the deployment manager, there's no such option available. You just create the machine using the deployment manager. You cannot execute any kind of pre-deployment script or post-deployment script. So deployment manager cannot be integrated with the Ansible. On the other hand, you can integrate the Terraform with Ansible, Docker, Puppet, but that option is not available with the deployment manager. So there are multiple factors why we choose the Terraform to spin up the resources in GCP over the deployment manager. You may face these kind of questions in your Terraform interview. So you should be aware that what is the deployment manager and what is the Terraform and why Terraform is preferable choice over the deployment manager. So thank you team. See you in the coming lecture. Hello team, welcome back. And today we will see how we can set up the GCP project for Terraform. So as a prerequisite, you must have the Google Cloud account. So if you already have your Google Cloud account, then that's very good. Otherwise, you need to create the Google Cloud account if you want to practice the lectures what we are going through. If you already have the Google Cloud account, then either you can use the existing GCP project or we will create a new GCP project for the practice of Terraform. Once you will decide about your project, we will create a separate service account in that project, and that service account will be used to connect your local environment to the GCP environment. Local environment is the environment where the Terraform is installed, and the GCP environment where we are going to create the resources using Terraform. Then we will create a basic Terraform source file to create the resources on GCP. So I already have my GCP account. I will log into my GCP account, and first we will do the project setup. So here we have opened the Google Cloud Platform. You can access your Google Cloud account on console.cloud.google.com. Very first, you need to select the project, or you need to create the project for Terraform. To select the project or create the project, you need to click this drop down. So I already have few projects in my account: admin project, my first project, and the service demo project. I'm going to use this particular project for Terraform lectures. But if you want to create a new project, you can click this link, new project, and you can mention your project name to create a new project. With a single account, only 25 projects are allowed. I have created the 3 projects so that I'm getting a limit of 22 remaining. I will cancel it and I will select the project where I want to work with the Terraform. So I want to work with the project service demo project. In your service demo project, you need to create the service account first. To create the service account, you can click this navigation menu, and over here you need to search for the IAM and admin. Within the IAM admin, you can directly go with the service account. The option is available over here, or you can click on the IAM and admin. IAM and admin is the access and management control for your cloud account. So you can see these are the IAM roles which I have already created. To create a new service account, you need to click on the service account option over here. 2 service accounts are already present within my machine. I will create one more service account, and to create a new service account, I will click on create service account button. Now I will provide the details. So I will mention my service account name. Suppose I'm putting terraform/admin. This is going to be my service account name. The email is autofilled with your service account name at the rate projectname.iam.gservicesaccount.com. If you want, you can put the description. It is always good to provide the description for your service account. I am providing description Terraform admin account. Let's click on create and continue. So now we need to provide the role to the service account. So for right now, we are providing basic owner role, and we will click on continue. Then it is asking user grant user access to the service account. If you want, you can provide the email over here like levelup360 gcp@gmail.com. This email is the owner email, right? Which is the owner of this particular account. Now I will click on done. So this will create the Terraform service account, and over here we are getting our service account. If you want, you can open it. You can see the permission on this account. You can see the roles we have assigned on this account. So we have the 2 owner roles. Then you can see the matrices. Then you can see the logs. Now once the service account is created, you need to go to the keys and you need to create add key. Within the add key, you need to click on create new key, and with the option JSON, you need to click create. Once the key will be created, it will ask you to download the file. So please download and save this file. This is a JSON file which will be saved in your local machine. So I will save this file. Let's see, I will go to my downloads and I will see if the file is saved. So you can see service-demo project, then the project id.json is saved. If you will open this JSON, then here is the JSON. This is the service type. This is the project ID. You are getting the private key, public key, client email ID, client ID, and the auth URI, token URI, and the other things. So this is a service account key which will be used to authenticate with the Google Cloud. So here we have downloaded the key. Please remember that we have created and downloaded the key. First, we will go to the Terraform configuration which we created for the GCP. Then we will see how we can use this key which we downloaded for a service account. So over here we have created a main.tf file or the Terraform file for the GCP. First, we are defining the provider, right? And then we are defining the resource. So first, let's talk about the provider. We are taking a Google Cloud provider. For the credentials, right now we are keeping it blank. We are defining a project where we need to define the project. Then we are providing the region, that in which particular region the resource will be created, and then we are taking the zone, in which particular zone of a particular region the resource will be created. So we will create the resource in US East 1 and we will use the zone US East 1 -c. Then we are creating a resource Google underscore compute underscore network. It means we will create a Google VPC network. The network name will be practice hyphen network, and auto create subnet true means that in each zone the subnet will be automatically created by the Google. So this is the basic configuration what we are going to execute first. Very first we will replace the project name over here. So we will go to the browser, and from here you can get your project ID. So right here we are using this particular project. So this is your project ID which you want to copy. Copy it and provide your project ID over here. Then what we will do, I will commit this file on a Git and I will download this file in my Terraform machine. Now I will go to the directory Terraform and execute git pull. The git pull is done. You can see there's a change in the main.tf. We will go to the folder where we have created the main.tf. So that folder is the Google. So we will go to the folder Terraform GCP introduction. So that is Terraform. So we will go to this directory Terraform GCP introduction, clear out the console, put ls. The file is here. Let's get main.tf, right? So we are getting the complete content. Now what we will do, we will create my JSON credential file over here. So I will go to my box and copy the file name. So this is my file name. I will click vi and paste my file name. Go to the insert mode, open your credential. Now you need to copy it and paste it here, right? Once you will paste your credential, press escape colon wq to save your file. You have saved your file. So at this particular location, what we have the main.tf and we have my service demo project.json. I will copy this JSON name, edit my main.tf file and go to the insert mode. Within the file, I will provide my credential JSON file right here, like this, right? So over here we have created the Google provider, we have provided the credential, we have provided the project, region, zone, and we have declared the resource what I want to create with a auto creation of subnet. Let's save this file, and in the coming lecture we will see what other prerequisites are required before starting or working with this particular main.tf file in Terraform. Hello team, welcome back. In previous lecture we have seen a basic setup of GCP account. Today we will see the basic APIs which we need to enable before starting with Terraform on GCP. So we will go to the Google Cloud account. On your Google Cloud account, you again need to go to the navigation menu and you need to go to the API and services. In API and services, you will click on the enable API and services link, and you can search the service or the API which you want to enable and disable in Google Cloud. So very first we will search for the Cloud Resource Manager, right? You are getting the hint Cloud Resource Manager API. So over here we are getting the two APIs, the Cloud Resource Manager API and Cloud Deployment Manager V2 API. We are talking about the Cloud Resource Manager API. We will open this API and you can see this API is not enabled for this project. So what we will do, we will enable this API. Let's wait, it will take few minutes. to enable the API. And once the API will be enabled, you will be redirected on the overview page of this particular API. Let's go back one more time, and we can see now on Cloud Resource Manager API, we are not getting the enable function, we are getting the manage function. Go back one more time and search for the another API, Compute Engine API. Here is the Compute Engine API. We need to enable this API as well. The Compute Engine API enablement will take some time, and if you are getting some warning like you need to activate your billing account and all, then you need to follow the Google instructions and enable the billing account by submitting your credit card details. Let's wait until the Compute Engine API will be enabled. We can see the Compute Engine API is enabled, and right now it is opening the overview page of Compute Engine API. Let's go back one more time and search for the another API, Cloud Storage API. We will click on the Cloud Storage API and we will open the Cloud Storage API. Let's enable this API as well. So we have enabled the three API: Cloud Manager API, Compute Engine API, and Cloud Storage API. All these API we enabled so that whatever we are going to execute by a Terraform, that will work seamlessly without any error. So these are the basic APIs which you need to enable before start working with the Terraform on GCP. Hello team, welcome back. And today we will see how we can set up the remote state file in Terraform. So we are already aware the importance of state file, and that is a very critical file for AWS, because in any case if you are going to lose your Terraform state file, then you are not able to track the resources which are being deployed as a part of that Terraform deployment. So Terraform remote state file is very important, and we have already seen that how we can create the remote backup of a state file in AWS lectures. But today we will see how we can set up the remote state file on the GCP Cloud Bucket or Google Cloud Bucket. So we already created some kind of configuration. First we will review that configuration, then we will see the basic setup of creating the remote state file. So this is the main.tf on which we was working. So we declared the provider, we declared the network, and this is the block what you can use to create the remote state file. Over here, first you need to define the Terraform block. Then within backend, you need to define the GCS. Within the bucket, you need to define your bucket name, and within the prefix, you need to define the subdirectory within your bucket. And over here, you also need to supply the credentials. So you need to supply the credential of service account which have the accessibility to create the data in cloud storage or in Google Cloud Bucket. So for this, first we need to log in our Google Cloud account and we need to create a bucket for this configuration. So we are on Google Cloud Console, and you need to make sure that you are working in the correct project in which you want to create the resources. Go to the navigation menu, and over here you need to go to the storage section. So we are getting the cloud storage. We will click on browse. So you will get a screen like this where you are within the cloud storage, and here all the buckets which are part of your project being listed. We don't have any bucket, so we will create a new bucket by click this link. Please make sure in Google Cloud the bucket are global entities. So this bucket is just not limited to your project, but that bucket name should be unique globally in Google Cloud. So we are creating the bucket name like Level Up 360 hyphen Terraform. Click on continue. Definitely we are going to create a multi-region bucket, and the location we are taking it within US. Click on continue. We are going with the standard bucket. Click on continue. We are going with the default option. Click on continue. Within the encryption setting as well, we are going to choose the Google managed encryption key and click on create. This will create a Google bucket within your project service demo project. So if you will click on the browse again, you will see the bucket is listed over here. Level Up 360 hyphen Terraform. Let's open this bucket and we will create some directory within this bucket. So we will click on the create folder and I will name it Terraform sample practice. Click on create. Now what we need to do, we need to copy my bucket name and we need to replace this bucket name over here with our real bucket name. In the similar way, we have the prefix. So you need to copy this folder name which you created within your bucket. So I will open this folder and you need to provide that folder name over here. So this is the way how you can provide the bucket and bucket folder name where you want to keep your backup state files. Now let's do some modification in this particular main.tf file. So within the credentials, we need to provide the credential name. So what is my credential name? Let's go to the Terraform and we will go to the directory where we have copied the credential. Let's put ls and this is your credential file name. So I will copy this name and put it here. Similarly, I will provide the same credential over here because I'm not going to create a separate credential for my bucket. This credential have all the rights. If you remember, then we have provided the admin right to this service account. So it will not face any issue to creating the bucket in your Google Cloud. Now let's save your file. And what we will do, we will commit this code changes. Once you will commit and push your code changes, now within your Terraform machine, you need to execute git pull. It will pull all the changes. Let's execute cat main.tf and you can see we are getting the service account changes. This is my project, region, zone, the network what I want to create, the subnet. It will create the subnet within this particular network. Here is the backend, the bucket, bucket prefix and credential. Now we will execute the Terraform in it and see we are getting that initializing the backend, initializing the provider plugins. So you can see it is installing the latest version of HashiCorp Google and installing the HashiCorp Google 3.81.0. If you want, you can specify the Google provider version as well. And even it is a good practice to provide the version. After this, we'll execute Terraform plan. Hit enter and let's wait for the plan. So it is saying that it is going to create the Google network, VPC network, and these are the values. Auto creation of subnetwork true, delete default route on create false. So it is going to create only one resource. If we will go to the Google Cloud, and in the Google Cloud, we will go to the navigation and we will go to the VPC, then you can see we only have the one VPC, which is a default VPC. Because whenever you create the account in Google Cloud, Google Cloud create a default network for you. So we only have a one network default network. Now to execute this plan, let's clear out your console and execute Terraform apply hyphen auto approve. It will not ask for the confirmation. Let's wait and it will deploy the VPC on your Google Cloud. So you can see it is creating the VPC network. We have to wait until the network creation will be done. So Terraform is providing the progress as well. And we can see that apply complete resource 1 is added, 0 changed and 0 destroyed. What is going to be the name of my VPC? The name could be practice-network. If you will go to the Google Cloud and refresh your page, go to the default and you can see the practice network is also being created. Because the auto subnetwork was true within your request, if you will go over here, you can see auto create subnetwork was true. So you can see Google Cloud has created the subnet for each region. And there are total 28 region in Google Cloud as a date while we are recording this lecture. So a subnetwork is created in each of the region. So this is the way how you can create the resources on Google Cloud using the Terraform. One more thing, let's open a new instance and let's go to the cloud storage. Within the cloud storage, we will open the bucket which we created for the remote state file. We will go to the directory terraform-practice and within this directory you can see we are getting default.tf state. The file size is 1.2 KB. So you need to click this link and you can see, and this is the file what we are getting, right? So this is version 4, this is the lineage and this is the provider and all the data regarding the resources what we created as a part of Terraform. If you will go to your local machine and you will put ls-a, then you can see we don't have the Terraform state file available in the local machine. Why? Because we have created the state file at the remote location within my Google Cloud bucket. So this is the way how you can create the file within your Google Cloud bucket. I will keep the file open. Now I will go to my Terraform and execute Terraform destroy. It will ask for confirmation, provide your confirmation, hit enter. So what it will do, it will destroy the VPC network which is being created as a part of this deployment. So let's wait until it will destroy the resources. So the VPC network is destroyed. If we will go to the Google Cloud, we will refresh this state file and see the content got changed because the resource got deleted. If we will go to the bucket and refresh this bucket, you can see the size of file is also reduced. If you will go to the VPC, refresh your VPC, you will see the practice network got deleted. Yes. So this is the way how you can create the resources in Google Cloud using the Terraform. Thank you team. See you in the coming lecture. Hello team. Welcome to Terraform training. Till this lecture, we have seen multiple sections in this course. We have seen the introduction part of the Terraform, the working model of the Terraform, the working model of the Terraform with the advanced level, and we have seen few case studies as well. In this section, I will explain about HashiCorp certification. So although I have explained the complete working model, but still if there are few areas which has not been discussed and still the part of the certification, we'll cover up these areas in details. So to go through the certification material, we will go to the HashiCorp official website. So here we are on the HashiCorp official website, hashicorp.com. Here in the resource, we need to click the resource and you will get a section certification. Click this certification. Here we are getting the complete information about the certification which HashiCorp provides. We are learning about the Terraform. So we will go with the Terraform Associate certification. We will click this link and here we are getting the prepare for exam and register for the exam. And here we are getting all details which is required for Terraform Associate certification. The prerequisite is basic terminal skills, basic understanding of on-premise and cloud architecture. Product version, this certification is for the product version HashiCorp 0.12. Here we have some preparing guide exam materials and here is the exam details. The format will be online, duration will be 1 hour, total cost is 17.50. This is plus locally applicable taxes. Here we have the complete curriculum of the exams. The first section is about the infrastructure as a code. The second section is about the understanding of the Terraform purpose versus infrastructure as a code, understanding of the Terraform basics, where the understanding of the handling Terraform providers, installation, demonstrate using the multiple providers, describe how Terraform finds the fetch providers, explain when to use and not to use provisioners, the questions about the Terraform CLI, interaction with the Terraform modules, native Terraform workflow, write, plan, create, init, validate, plan, apply, destroy, implementation and maintenance of the state files, read, generate, and modify the configuration of Terraform, and understanding of the Terraform cloud and enterprise capability. So these are the part of this section. And if you are going with the HashiCorp certification, then you need to learn about this curriculum. So what is the material over here in the exam objectives? We are going to discuss about this material. If this material is still not covered in this course or less covered in this course, we are going to cover that thoroughly. So that if you want to go with the HashiCorp certification, you can try HashiCorp certification after this course. So thank you team. In the coming lecture, we will discuss about the first module IAC, which is infrastructure as a code. Hello team, welcome to Terraform training. And today we will discuss about the first section of Terraform certification, understand infrastructure as a code concepts. So let's start with. So in the very first section of the Terraform certification, we need to understand what is IAC and what are the advantage of the IAC. So this is the section name and these are the subcomponents of this section where first is explain what is IAC and second is describe advantage of IAC patterns. So we have not discussed much about IAC in this course. So we will discuss about the definitions of the IAC and the advantage of the IAC in the modern DevOps world. So first, let's go with the definition. But before going with the definition, first let's try to understand why we need IAC. What is the requirement to invent the IAC? So in the past, when big IT companies were working on the big project, the management of the IT infrastructure was a hard job. And to manage the infrastructure, system administrator had to manually manage and configure all of the software and the hardware that was needed for the application to run. So that was a really critical and really tedious job, because human need to set up the software and the hardware which is required to execute your application. But when the things evolve with the cloud computing, when the public cloud providers provide the automatic infrastructure, the things are basically changed dynamically. Now, nobody needs to manually sit and configure the complete hardware and the software manually. There is a lot of tools available in the market which can automate this job. And this is called IAC, which is infrastructure as a code. If we will go with the definition, then infrastructure as a code is process of managing and provisioning computer data centers through machine readable definition files rather than physical hardware configuration or interactive configuration tools. That is the definition of the IAC. But in simple word, in my word, we can simply mention that infrastructure as a code means to manage your IT infrastructure using the configuration file. That is the simplest definition which I really like about the infrastructure as a code. Now let's discuss what exact problem does IAC solve. So historically, managing IT infrastructure was a manual process. People or the system administrator physically put servers in place and configure them. Only after configure the machine, they will configure the OS, the required utilities, and once they will execute the application, they basically encounter with the new issues. Sometimes this took several hours or several days as well. So the first problem is someone is doing the job manually, and that job is error prone, right? That job is taking the time. And the another big problem is the cost. You would have to hire many professionals to perform the necessary task on each step of the process, from network engineer to the hard rock maintenance engineer. Because whenever we are going to configure the infrastructure, we need to manage the network, we need to manage the hardware, we need to manage the support utilities, we need to manage the support tools, we need to manage the performance tuning as well. And all these things are quite complex, and this requires a lot of money, because to operate the complete infrastructure and to manage the complete infrastructure is really a costly job. So we have discussed the problem of the latency, we have discussed the problem of the cost, and the third problem is the scalability and availability. These infrastructure may be scalable or may not be scalable. The availability is the another problem. Somehow if single server is going down, it may possible that all connected server will go down and your production may face complete blackout. Scalability is also an issue. Sometimes the people configure the server in a way that they can be scalable. Sometimes to scale the software is almost impossible. So if the traffic on your website or traffic on your application is reaching the limit and your application is consuming the maximum resources available on the server, you cannot add more resources to your server, so that you cannot support more customers. And the last but not least is the inconsistency. Suddenly server may go down, suddenly server may crash, and that will take a lot of time. So we have the inconsistency. Inconsistency is also in terms of the multiple server configuration. Suppose person A is configuring the server A, person B is configuring the server B, or a same person is configuring the two servers for the same application. It may possible that on server A he has done some other configuration, and on the server B he has done some other configuration. That difference may be in the version of the tools, the utilities, or maybe in the hardware, maybe in the software. And the solution is the IAC, which is the missing piece. So again, we will go through the definition. Then the definition is infrastructure as a code means to manage your IT infrastructure using the configuration file. The key takeaway from this definition is the before IAC, IT personnel would have to manually change configuration to manage their infrastructure. Maybe they would use the throwaway scripts to automate some task, but that was extent of it. But with IAC, your infrastructure configuration takes from the code files. Since it's just a text, it's easy to edit, copy, and distribute. You can, or maybe you should put the code inside the version control or code control management system like the other codes of your application. So IAC solves a lot of problem regarding the provisioning of the infrastructure. So let's discuss about the key points of the IAC. So if we are going to provision the servers even on the cloud, instead of going through the UI, we can write down the code files to create the resources on the cloud or on-prem. We can manage the code of infrastructure in the version control system, as we are versioning the code of my application. We have the ability to review the process, because whenever we are going with the IAC, we are creating the code files. These code files are also versioned, so we may review the complete process, that what is the process we was following in the previous release and what is new in the process in the current release. We may also update the code, we may also update the IAC code as per the cloud update. So if cloud have some new feature, we want to update that feature, then we can add that code. And definitely whenever the new release is going to put on the production, the updated cloud resources will be used and updated code files will be used. Although at the same time, if you want to provision the software from the previous release, you can use the previous release as well. And the another benefit is the code reusability. Suppose you have the multiple production systems, you have the multiple regression systems, and you want to spin up the same infrastructure or across the productions, so you can use the same code files to provision the multiple production systems. Automation of the data center provisioning, definitely that is the basic point of the IAC. You can automate the complete provisioning of your infrastructure. That could be the data center, that could be the servers, that could be the database, that could be the file system, that could be anything which is available on the public cloud and for which you can do the IAC. Now let's discuss about the benefits of the IAC. So till now we only have discussed about the problems and the IAC. Let's discuss about the benefit of the IAC. And the first significant benefit is the speed. Infrastructure as a code enables you to quickly set up your complete infrastructure by running the script. So infrastructure as a code enable the user to quickly set up the infrastructure by running the script. You can execute a script and you can set up the complete infrastructure in few seconds. So if we will go through the previous labs, then you can see in just 5 to 10 minutes we was able to set up the complete VPC, Kubernetes, worker nodes and the other security groups. So a lot of resources we have created in just few seconds. If we are going to configure these resources manually, then definitely it will take some time. So speed is the factor which is the benefit of the IAC. IAC is also helpful if we are going to provision the infrastructure across the environment. You can use the same IAC file to provision the development, production, staging, QA, and any other environment which is required. And at last, I would like to mention that IAC can make the entire software development lifecycle more efficient. The another factor is the consistency. Consistency was the problem with the manual or handcrafting systems, because humans are fallible and our memories fault us. Communication is hard and we are generally pretty bad at it, as we have learned that the manual infrastructure management will result in the discrepancy. You, no matter how hard you try, but definitely you will do some mistakes if you are going to configure the complete infrastructure manually. IAC solved that problem by having the config files themselves, and a single source of truth file is present to provision your complete infrastructure. That way you guarantee that the same configuration file will be deployed over and over and over and over across the environments. The another benefit of the IAC is the accountability. This is a one quick and easy, since you have a version of the IAC configuration file, like you have the source code management for your IC file, you have a full traceability of the changes. What changes is being done in the previous release, in that previous release, in that previous release, and what changes you are planning in the current release. So there is no more guessing game. You can identify each and everything very easily. You just need to version your IAC code. The next benefit and important for any business is the lower cost. No doubt IAC is managing your cost. IAC can dramatically reduce your business cost, because we don't need to spend a lot of money on the engineers. We don't need that we need to set up 25 or 30 engineers to set up the infrastructure manually or provision or operate the infrastructure manually. Two or three DevOps or the SRE engineer will be enough to provision the complete infrastructure, right? To manage the complete infrastructure, because a lot of things has been already moved on the cloud. So cloud is already managing your infrastructure. You just need to sit and set up your infrastructure. And if we are going to set up the infrastructure with the help of the IAC, we are basically setting up the infrastructure very quickly, and if we want to destroy, we can destroy it very quickly. And definitely that thing is a cost savior. So team, that is about the first section of the certification, which is IAC. In the coming lecture, we will discuss about the second section. Thank you team. See you in the next lecture. Hello team. Welcome to Terraform training. And today we will discuss on section 2 in certification.
and the section title is Understanding of Terraform's Purpose. So let's go through the content which Terraform mentioned in the section 2. So section 2 in Terraform certification is the understanding of the Terraform's purpose. The first part is explain multi-cloud and provider agnostic benefit, and second point is explain about the benefit of the state file. So we have discussed about the state files a lot in this course. So I hope everyone is pretty much clear what is the state file and what is the use of the state file. What is the multi-cloud and cloud agnostic benefits? Multi-cloud means whenever we are going to create the infrastructure on multiple cloud providers, we are not going to stick with a single cloud provider and we will create the complete infrastructure on a single provider. That's all not a great idea. So what we will do, we will pick up the services from the multiple cloud providers, that is called the cloud agnostic service. So let's discuss about the cloud agnostic service and the benefits of cloud agnostic services. Cloud agnostic infrastructure is where we are creating the service on multiple cloud. If we have a cloud infrastructure, then different cloud providers are the part of that infrastructure. Some of the services we are using for the GCP, some of the services we are using from the AWS, some of the services we are using on-prem or some other cloud provider, some services we are using on Azure. That kind of infrastructure is called the cloud agnostic infrastructure. Or it may also possible, the second form is that we are running the primary site on, and there's one more kind of cloud agnostic infrastructure, that we are running the primary and the secondary site on different cloud providers. So we are running the primary side on AWS, and it may possible that we are running the disaster recovery side on the GCP, or we are running the primary side on the GCP, or running the disaster recovery side on the AWS. So that is also example of the cloud agnostic infrastructure. What is the benefit of this? So very first benefit is the flexibility, right? Flexibility is one of the greatest benefit of the cloud agnostic infrastructure. When we mention about the flexibility, you are flexible enough to stick with different cloud providers. If some services are not working in a single cloud provider or your primary cloud provider, you can go with these services in the another cloud. If some services of the cloud is not good for your business and you want to adopt the same service from some other cloud provider because they are providing the lot of features and additional things in terms of the performance, you can go with that cloud provider. So it may possible that you are running the Kubernetes engine on Google Kubernetes engine, but you are running the instances on AWS. It may possible you are using the complete execution machine on the Google Cloud, but you are using the AWS database, or you are using the AWS credential store, or you are using the AWS centralized logging, right? So we can use the different flavor of different cloud. Being cloud agnostic means that you are capable of switching tracks to different public cloud providers with minimal disruption of your business. Suppose you are executing your complete business on Google Cloud, and due to some regions the Google Cloud is down. So what you will do? It will suffer your business. So the better way is your plan should be ready and you can shift your business completely to some different cloud. As I mentioned earlier, you can make the PR side and DR side on different clouds. You can make your primary side on GCP and you can make your secondary side or disaster recovery side on the AWS. You can make the primary on AWS and make the secondary on GCP as well. So due to any reason or the outage at the cloud provider side, we can simply switch to the another cloud and that will not impact our business. The another reason that company want to embrace this strategy is to avoid the vendor lock-in. Vendor lock-in means we are not completely dependent on a single vendor. As I told you that if some particular cloud is down, then it will not suffer our business, right? We are not completely dependent on a single vendor. Now, how Terraform will help us in the cloud agnostic infrastructure creation. So Terraform is a cloud agnostic and allow a single configuration to be used to manage multiple providers and to even handle cross cloud dependencies. So with the help of the Terraform, you can create the single configuration file, and that configuration file will be able to execute on multiple clouds. You can execute the same file on GCP, on AWS, and Terraform will also handle the cross cloud dependencies. If there is some kind of dependencies, suppose we are executing some services on AWS and some services on GCP, and we have such dependency that the provisioning of GCP services will only happen after the AWS services. So we can mention that dependencies as well, and Terraform will maintain that dependency for us. Now let's discuss about the purpose and benefits of the state files. So we have already discussed state file is the heart of Terraform. State is necessary requirement for Terraform to function. Without a state file, Terraform cannot function because Terraform don't have any record that what resources is actually executing on the cloud and what resources is being created with the help of the Terraform. State files are some sort of database to map Terraform config with the real world. Definitely, the Terraform state files are the database for the Terraform, because with the help of the state files, Terraform can determine that what resources are running on which cloud and what is the configuration of that resource. If there is some change in the configuration and you are going to execute the Terraform again, then Terraform will identify the change and it will correct it. Alongside of the mapping between the resources and the remote object, Terraform must also track the metadata such as resource dependencies. The all properties which is being pushed with the help of the Terraform, Terraform will take care all these things with the help of the Terraform state files. So once the infrastructure will be provisioned, Terraform state file will be the database for the Terraform. And in any case, you won't lose your Terraform state files. If you are losing your Terraform state files, then definitely that's not a good signal. And all the resources which are running on the cloud, you don't have any option. You just need to go and manually terminate these resources, because Terraform destroy will not work in that case. For every plan and apply, Terraform will sync all the resources in your state file. So whenever we are executing the Terraform apply, Terraform will sync all the resources which are running on the cloud with the Terraform state files. In our earlier lectures, we have also discussed the local versus remote state files, and we have also seen how we can create the versioned remote state files and how beneficial these are. Whenever we are working in the distributed manner, we have a team, not a single person is working on the Terraform, then definitely the remote file is the ideal option in that case, because that provides a lot of functionality and that provide a lot of liberty to us. So that's about the part 2, team. If you have any question, any doubt, you can ask me. Thank you, team. See you in the next lecture. Hello, team. Welcome to Terraform training. And today we will discuss about the section 3, which is understanding Terraform basics. So the objective of this section is to start with the Terraform. So in the section 3, understanding of Terraform basics, we have the 5 subcomponent. Today we are going to discuss about the first 3 component. And first one is handle Terraform and provider installation and versioning. The second is describe plugin based architecture, and third is demonstrate using multiple providers. So over here, let's discuss about the handle Terraform and provider installation and versioning. Here, the Terraform versioning is no more required, that is deprecated, and in the latest version of Terraform, we are not bound to use the versioning in Terraform configuration. So Terraform configuration must declare which provider they require. So whenever we are going to create the Terraform configuration, we need to define the provider. So in this course, we use the provider AWS. If you are going with some other providers like Oracle Cloud, Microsoft Azure, Google Cloud Platform, then you need to define these providers. But Terraform provider declaration is must in Terraform configuration file. Provider configuration belongs to the root module of Terraform configuration. Yes, that is very basic and very necessary. If you are not defining the Terraform provider, then Terraform will not be able to initialize the Terraform. So if you remember, whenever we was creating a new Terraform directory, right, we was executing a command Terraform in it. If you are not defining the Terraform provider in the Terraform and you are going to execute Terraform in it, then Terraform will not initialize. So provider is a very required configuration in Terraform that belongs to the root module of the Terraform. In our labs, we have seen the AWS provider example, and here I'm attaching an example of the provider Google. So we are defining the directory provider, then we are defining which provider we want to use. In case AWS, we define the AWS. In case Google, we are defining the Google. Then in Google, we have the projects. If you are familiar with the Google Cloud, then within a single account, you can define multiple projects, right? As I believe with the free account you can define up to 6 projects, and with the commercial account you can define up to 11 projects. So in Google Cloud you need to define the project, which is not the concept in the AWS. So if we are going to define the provider Google, then we also need to define the project ID over here. This is a sample project ID, and we need to define the reason as well. So reason in Google and AWS is almost similar. There's a very little difference in the reason naming conventions, but you need to define the provider, project, and the reason. If you have any question that what providers are available with Terraform, then you can go to the registry.terraform.io. So I'm going with the registry.terraform.io, and you can see on the home page Terraform is listing out the providers. Providers are plugin, implement, resource type, and here is few featured providers: AWS, Azure, Google Cloud Platform, Kubernetes, Oracle Cloud Infrastructure, and Alibaba Cloud. These are the popular providers, but if you want to go through the complete list, you can click this and you will get the multiple providers over here. So you can see we have a multiple providers over here, and you can use any of these provider as per your requirement. Whenever we are going to define the provider, there is a one more thing which is called alias. Alias can be used to define the multiple provider configuration. So we have not seen the use of alias in our labs, so that I'm defining over here. So the main use or main purpose of the alias to define the multiple configuration for the same provider. Here is an example. So suppose first we are defining the provider AWS region US East -1. Then for the reference, we are defining the same provider again, provider AWS, and we are defining alias West. And over here we are defining the region US-West-2. So over here you can see we have the same provider, but we have defined the provider two times. And second time we are defining the alias as well. And over here you can see the reason of both providers are different. The default reason for the provider AWS is US East 1, but the default reason for the alias is US West 2. So whenever you are going to define the resources, and suppose you want to spin up few resources in US East 1, and in the same configuration file you want to spin up other resources in the US West 2. So you can take the reference of the alias. The default resource will join the AWS provider, which is the default provider, and they will deploy in US East 1. But if you are specifically defining the provider AWS.West, it means the provider name then the alias name, then that resource will deploy in region US East 2. So I hope you are able to get the use of the aliases. With the help of the aliases, you can distribute the resources across the providers, or with the same provider but across the regions. Let's see how we can select an alternative provider configuration. So whenever we want to spin up the resource with the alias, right, we can define the provider inside the resource. So suppose here I'm defining AWS instance, so I will explicitly define the provider equals to AWS.West. It means this resource will spin up in US West 2, because for the alias AWS West, I have defined the region US West 2. If you are going to use the alias in module, then you can use the alias in module like this way. We will define the module, we will define the source, and we will define the provider, and we will define the provider AWS equals to AWS.West. Here first AWS is the name of the provider, and second AWS.West is the alias. Now let's go with the second one, describe plugin based architecture. So we have seen that Terraform installed in my local machine. And whenever I have created any directory, after the creation of the directory, I always executed a command Terraform init. So Terraform use a plugin based architecture to support the hundred of infrastructure and service provider. And that Terraform plugin will dynamically installed on your machine in each Terraform directory after reading the provider. So whenever you are initializing the Terraform configuration with the help of the Terraform init, Terraform configuration first read the Terraform provider, and as per the provider, Terraform will install the plugin on your box. So you can go to the earlier labs and you can see whenever we have executed the Terraform init, we got three lines as output: installing HashiCorp version 2 dot something, installing the AWS provider plugin, and installing the supporting resources. So it means Terraform initialization is nothing but it will install the plugin in the directory as per the defined provider. If you want to format your configuration, you can execute a command terraform fmt. This will format your configuration file. If you want to validate your configuration file, then you can execute the command terraform validate. And if your configuration is correct, you will get a message like success, the terraform configuration is valid. If you want to see, I can show you. So we are on the terraform machine. We will go to the directory terraform. Then we will go to some directory. So earlier we was working on this directory terraform demo1. Let's go to demo. If I will put ls, then here we have few configuration file like create instance.tf and variable.tf. Let's execute terraform fmt to format the files, and this will list out the number of files which are present on your directory. So here we have the two files, create instance.tf and variable.tf. Terraform fmt has formatted these files. If you want to see, let's get some files like variable.tf and see this file is formatted. If you want to see it again, let's do one thing. Let's edit this file variable.tf and let's remove the format. So we are removing the format like this, right? Let's remove this as well. So you can see this file is not formatted. I will simply save it and execute the terraform format again. So suppose we are saving like this. Let's save this file, clear out the console and execute the format again. You can see we are getting the file which is being formatted by the terraform. The create instance.tf is already formatted, and now it just formatted the variable.tf because we have removed the formatting. Let's get this file and see it's again formatted. So terraform fmt will format your configuration files. If you want to format your files, you can use the simple command. Similarly, we have the terraform validate, and terraform validate will validate your configuration file. If you want to validate your configuration, you can use the terraform validate, and if the configuration is correct, then you will get a message like success, the configuration is valid. So these are the commands which you can use to format and validate the file. Terraform init, you are already aware about the terraform init. If you want to execute the terraform init, you can execute it so that you can get the output as well. And see, we are getting initializing the backend, initializing provider plugins, right? Using previously installed HashiCorp AWS version 3.23. It means the required plugins are already installed previously. So team, this is about the third section, right? In the coming lecture, we will continue this section. Thank you. See you in the next lecture. Hello team. Welcome to Terraform training, and we are learning about the third section of Terraform certification objectives. This is understanding Terraform basic 2. So over here, we will discuss about the provisioners and the providers. So in the earlier lecture, we have discussed the first three part of the understand Terraform basics, and now we will discuss about the rest of two. So first is the describe how Terraform finds and fetch the providers, and second is explain when to use and not use provisioners and when to use local exec and remote exec. So these are the 2 points, and over here the first point is describe how the Terraform find and fetch the providers, and I believe we have already discussed it. We have discussed about the providers. We need to mention the providers, which is the root module of the Terraform, and Terraform init will find out the providers and download the required plugins. We will discuss about the second one, the provisioners, local exec and the remote exec. First, let's discuss about the provisioners. What are the provisioners? When we can use the provisioners? Provisioner can be used to event a specific action in order to prepare server for the service. So whenever we want to execute something on the servers, which is a event base, we need to use the provisioners. Although Terraform is very rich in resources, but sometimes we have these requirements that we need to execute something server during the configuration or after the configuration. And in that case, provisioner is the option, right? With the help of the provisioner, you can execute any executable thing on your remote servers. And the first use of the provisioner, if we want to passing some data to the virtual machine, we can use the provisioners. Terraform have the multiple provisioners to pass the data to the public cloud, but first we need to understand why we need to pass the data to the virtual machines. So we can pass the data to the virtual machine. Suppose we want the SSH connection with the machine. Suppose we want to create the SSH connection with the machine. We want to pass some key to the machine. We want to pass some service account, some credential to the machine. Then we can use this provisioner. And to passing the data to virtual machine, we need to use the user data provisioner. User data provisioner is applicable with AWS Cloud and Alibaba Cloud. For the Google Cloud Platform, we need to use the metadata, and for the Microsoft Azure, we need to use the custom underscore data. So these are the provisioners which we can use different cloud platforms if we want to pass some user data to the cloud. Now let's discuss about the local exec, right? Local exec and the remote exec are also the provisioner. We need to understand when we can use the local exec and when we can use the remote exec. So local exec provisioner is used to run the CLI for your target system in order to create, update or interact with the remote object in the system. It means we can use the local exec provisioner whenever we want to execute something command line for the target system which will interact with the remote object. It means this local exec is running on the local machine where Terraform is executing, right? Because it is interacting with the remote object. With the help of the local system, you can create, update the remote object resources. It means you can create and update the Terraform state file. You can record some configuration and later you can update that configuration in the Terraform state file. So local exec is something which will execute on the machine where Terraformer is executing, but it will read the data from the remote resource. So the resource local data we can read with the help of the local exec, and that data can be useful in the remote object which is present on the machine where Terraform is executing. We can take an example. If we are trying to use a new feature of the remote system that is not supported by the Terraform, then we can use the local exec. So if there is any feature which is the part of the public cloud, but Terraform is still not supporting that feature, right? But we want that feature in the configuration, in the Terraform configuration, then we can use the local exec. Here is a sample that how we can use the local exec. So we need to define the resource. Suppose over here we are defining the AWS instance. The name of my instance is server. I will execute, I will mention the provisioner, then I will mention the local exec. And over here I'm executing a command with the help of the local exec. Echo the server IP address is self.private IP. So you can see over here I'm reading the private IP of the machine which I am creating. So over here you can see I'm basically getting the private IP of my terminal. So suppose if I don't have any feature to read the private IP of the resource which I'm creating, then we can use the local exec, right? And this is the way how you can retrieve the private IP of your machine. If you remember that in the earlier lecture we have used the self, right? So why we used the self? Because the expression in the local exec provisioner block cannot refer to the parent resource by the name. So till date, we have seen this in multiple labs. Whenever we require to read some data from the resource, we use the resource name. But expression in the provisioners cannot read the parent resource. So that we can use the special object which is called self. Self will basically attach with the resource which it is creating. Whenever you are defining the self, it will basically retrieve the data of the current resource which is executing the provisioner. By default, the output log of the local provisioner will not be visible on the CLI. All logs output from the provisioner is automatically surpassed to prevent the sensitive value from being displayed. So with the help of the local exec, if you are executing something, you are getting something, then the log of that thing will not be visible on your Terraform terminal. In earlier labs, we have seen whenever we was executing the remote exec, whenever we was executing the file, we can directly get the log of these provisioners on the terminal. But if we are using the local exec, then we cannot get the logs on the terminal. Now let's discuss about the remote provisioner. So remote exec provisioner invoke a script on remote resource after it's created. So remote provisioner can be used to execute any kind of script or any set of script on the remote machine which it is creating, right? On the resource which it is creating. But local exec can be used to read the resource data, resource local data. Over here with the help of the remote exec, we are not reading the resource local data, we are executing something on the remote exec. That could be the Ansible playbook, that could be the chef code, that could be the cloud init, that could be the shell script, Python script, Java files. right? Anything which you want to execute on your remote machine, you can execute that particular thing with the help of the remote exec. And anything which are executing as a part of the remote exec, the log of that particular stuff will print on terminal. Remote exec support multiple kind of argument. The first argument is the inline. This is a list of the command string. They are executed in order they are provided. So if we are defining the remote exec and we are defining the argument inline, that inside the inline we will define an array, right? And after that we can define the multiple commands, the comma separated command which we want to execute on the server. And these command will execute on server in a specified way as they are mentioned in the remote exec. The second is a script. The second is a script. If we are defining the script argument in the remote exec, then we need to define the path of the local script, right? Local script means the script must be present on the box which is executing the Terraform, and we need to define that path so that that script will be copied on the remote machine and then it will execute on the remote machine. And third and last is scripts. The only difference between the script and scripts is in the script we can define the list of path, right? We can define the multiple scripts with the help of the scripts, but with the help of the script we can only define a single script. So scripts argument is helpful whenever we want to execute the multiple scripts on the remote machine. We just need to define the path of these scripts. These scripts will be copied on the remote machine, and these scripts will be executed in the same order as they are defined inside the scripts. But here it will raise a question: how to execute the script with the argument? The script which you are executing on your remote machine, suppose the script requires some argument, some runtime argument, then how can you pass these argument to the script? That is the biggest question. So not inline, not script, and not scripts can support this kind of execution. For this we have the another way, and the way is user will upload the script with the help of the file provisioner, then it will use the inline argument to execute or call these scripts. So here is the sample output. Suppose we are defining the resource AWS instance, the name is server, and suppose you want to execute the test underscore shell script on my remote. But this script required the multiple arguments, right? So what we will do first, with the help of the file provisioner, we will define the source of that script on my box, and we will define the destination of that script on the remote machine. What this file provisioner will do, file provisioner will simply copy this script from your local box to the remote machine, and then with the help of the remote exec inline argument, see in the second part, we can define the commands which we want to execute. So you can see we are defining an array after the inline. First we are defining the command which is going to make the test underscore shell script executable. You can see chmod plus x, and then we are simply executing the test script sh with the multiple arguments. So this is the way if your script is requires some argument to execute a runtime, so you cannot execute your script with the help of the scripts and script. I hope we are pretty much clear about the remote exec and the local exec and the execution flow of the remote exec and local exec. There are few more provisioners. The first is creation time provisioners. So by default, provisioner run after the resource creation. Whenever you are defining the provisioner, either that is a either that is a local exec, either that is a file, either that is a remote exec, the default behavior of the provisioner that it will execute after the resource creation. But what if we want to execute some provisioner during the resource creation or on some condition basis? What is the way? So we can definitely define the creation time provisioners in Terraform. Creation time provisioners are only run during the creation, not during update or any other life cycle. It means whenever we are defining the creation time provisioner, that will only execute during the creation of the resource. It will not execute in any other part. If we are doing the Terraform apply, which is updating the resource, if we are executing the Terraform destroy, any other life cycle we are executing in the Terraform, that provisioner will not execute. It only and only execute during the creation of your resource. The another question is what happen if the creation time provisioner fail? So in Terraform, if the creation time provisioner fails, then Terraform will mark the resource as tented. Why this is not marking the resource as successful? A tented resource will be planned to destruct and recreate upon the next Terraform apply. It means During the creation time, if the provisioner got failed, right, something not gone as per the instructions you have mentioned, then Terraform will mark that resource as tented. It will not mark the resource as a successful. And whenever you will modify your provisioner and you will execute the Terraform apply again, first Terraform will destroy that resource which is marked as a tented, and then it will recreate it. You may have the question why Terraform is not making the resource successful. Because provisioner is not a Terraform thing, right? Provisioner is executing something which is being created by you, the script, the local script you want to execute on your remote server. So Terraform doesn't know the actual state of that resource. Terraform doesn't know the actual failure reason of that thing. So to prevent the incorrect infrastructure creation, Terraform will simply mark that resource tented, and whenever you will modify your provisioner definition, whenever you will modify the script which you are executing as a part of the provisioner, and you will again execute the Terraform apply. So Terraform first destruct that resource which is marked as a tented, and then it will reapply or recreate that resource. Let's discuss about the provisioner failure behavior. So by default, provisioners that fail will also cause the Terraform apply itself to fail, right? The on failure setting can be used to change this setting. Suppose you don't want to mark your resource tented if anything inside the provisioner is failing during the creation time or during the local exec or the remote exec. Then what is the option? The option is on failure setting in the provisioner. You can mention the on failure setting which comes with the two default option. The first is continue. It means ignore the error whichever being done during the provisioner execution and continue with the creation or destruction of the resource. And second is fail. It means raise the error, stop applying anything after that error if the creation provisioner fails, tented the resource, right? So these are two settings which comes with the provisioner if we want to move forward with the failure, or we want to completely stop anything creation after that failure in the provisioner state. This is the resource definition which you can make. You can define the resource, the name of the resource, you can define the provisioner, the type of the provisioner, then you can define the arguments which is supported by the provisioner, then you can define on failure equals to continue or fail as per your requirement. So thank you, team. But I forgot to mention one thing. There's a one more kind of provisioner which is called destroy. So if you want to execute something, whenever you are going to destroy your Terraform resource, then you can define that particular provisioner as well, right? For that, inside the provisioner, you just need to mention a condition when equals to destroy. Whenever you will mention a condition when equals to destroy, like we mentioned the condition over here on failure equals to continue, right? Whenever when equals to destroy will mention inside your provisioner, so the command which are part of your provisioner will only execute whenever you will execute the Terraform destroy, and the failure behavior of that provisioner is the same like the creation time failure. It means if during the destroy of the resource your provisioner will fail, then Terraform will mark your resource as a tented and it will not destroy the resource. In that case, the Terraform on failure continue is a very important stuff. It means suppose you want to destroy the resource, you also want to execute some script that maybe, like if we want to take an example, we can take an example. Suppose we want to destroy the resource, and whenever the resource destroy is happening, we want that the same resource DNS record can be erased from the cloud, or we want that if that resource is the part of the ILB, then we want to remove that resource from the ILB. Then we can mention these kind of script in the destroy provisioner. But we also want that if the scripts are failing, we are not going to stop the destroy process, we will simply go with the destroy. Then we can mention the when equals to destroy, we will define our commands, and in last we will mention on failure equals to continue. So it will execute the commands, but if commands will fail, the provisioner will fail, it will still continue the destroy of your resource and it will successfully destroy your resource. So thank you, team. I hope the information we just shared, that is important information and it will help you in the certification. Thank you, team. In the coming lecture, we will discuss about the another section of the Terraform certification. Hello, team. Welcome to Terraform training. And today we will discuss on section 4. Section 4 is about use of Terraform CLI. So Terraform certification section 4 is all about the use of Terraform command line. Here is a part of the Terraform command line section, the use of Terraform FMT command, which is format code, the use of Terraform tent command, the use of Terraform import, use of Terraform workspace, and use of Terraform state. And in last, we will see enabling verbose logging in Terraform. So first, let's discuss about the Terraform FMT. Terraform FMT command is used to rewrite the Terraform configuration file to a canonical format and style. We have already seen the use of Terraform FMT in the same section, and with the help of the Terraform FMT, we have formatted few files in our Terraform directory. So Terraform FMT don't have any functional use. This command can be used just to format the Terraform configuration in the canonical format, so that it will be easy to read the Terraform configuration, which makes it easy to read the Terraform configuration for the common user. The next command is Terraform tent. The Terraform tent command manually marks a Terraform managed resource as a tented, forcing it to destroy and recreate on the next apply. So with the help of the Terraform tent command, you can mark any Terraform resource as a tented resource. Terraform tent command just mark the resource tented in the Terraform state file. And whenever next time you are going to execute the Terraform apply, Terraform will terminate that resource which is marked as a tented, and it will recreate that resource from a scratch. So suppose you have deployed few resources with the help of the Terraform, and you want that few resource will recreate every time whenever you will perform the Terraform apply. In that case, just after making the resources, you can mark these resource as a tented resource in the Terraform state files with the help of the Terraform tent command. This command will not modify the infrastructure but does modify the state file in order to mark the resource as a tented. So as I told you, Terraform tent command just mark the resource tented in the TF state file. It will not impact the resource in the infrastructure. You can use the Terraform tent command in this way. You can mention the Terraform tent and then you can mention the resource ID, right? Whatever the resource ID you will mention after the Terraform tent will mark that resource tented in the Terraform configuration file. The next command is the Terraform import. Terraform import command is used to import the existing resource into the Terraform. So if you have any resource on your infrastructure and you want to reconfigure that resource in your state file, then you can use the Terraform import command. Whenever you will work on Terraform, you will not use these command Terraform import very frequently, right? But if you are doing some modification on the infrastructure, you are modifying the resource, you are changing the resource configuration, then you can import the resource again with the help of the Terraform, so that the same configuration can be imported in your TF state files. So if you are doing some manual modification on your infrastructure, right, then you can use the Terraform import to import that resource structure in your Terraform state files with the help of the Terraform import command. So here is the example of the Terraform import. You can define like Terraform import, then you need to define the resource which you want to import. Over here we are mentioning AWS underscore instance. So this is the AWS instance resource. Then you need to mention the name of that resource. So in that case, suppose I want to import the instance information in a resource named test underscore ins. And then you need to define the ID of that resource for which you want to import the information. So over here, suppose my resource have the ID I-1234. So here is the Terraform import command which will import the resource definition from your infrastructure to your Terraform state file. The next command is Terraform workspace, and Terraform workspace is used to store the Terraform persistent data. So if you are from the programming background or you have used any ID, then you must be aware with the workspace, right? Workspace is something where you will store all your work. With the same definition, Terraform has created a new concept of the workspace, and in a single and that workspace will be used to store the persistent data of the Terraform, that is the Terraform state file. So suppose you have created some directory and you have created a new workspace, new Terraform workspace in that directory, which is called test. Initially backend have only one workspace called default. So if you are not creating your own workspace, then Terraform have the default workspace only. If you want to create a new workspace, you need to specify the command like Terraform workspace new, then the name of your workspace. So over here we are creating the test workspace, and once the workspace will be created, you will get a message like created and switch to workspace test. Now let's understand the use of workspace. So suppose you have created some configuration file, and these configuration file are ready to use in the production. But before executing the same configuration in the production, what you want to do, you want to execute this configuration in the staging environment. So you can create a workspace in the Terraform called staging, and you can execute this configuration file. Once the execution will be done, your sanity will be done. Now you want to execute the same configuration in the production, so you can switch to the production workspace. Production workspace will not communicate with the staging workspace, right? They both are the separate thing. So the state files, the data which Terraform has created for your staging environment, although they are using the same directory, they was using the same configuration file, that will not interact with the workspace which you have created for the production. So workspace is something which will isolate your work, right? Within the same directory you can create the multiple workspace, and these workspace will be completely isolated from each other, right? By this way you can create the multiple environment with the help of the same configuration file at the same directory, without making the copy of that directory and making a completely new Terraform project. As I mentioned that the named workspace allow conveniently switching between multiple instances of single configuration. As we have discussed, the common use of multiple workspace is to create parallel and distinct copy of the set of infrastructure in order to test the set of changes before modifying the main production infrastructure. We are already aware with the Terraform state file, so I'm not going to mention or discussing the Terraform state files again and again. And we are moving to the next, which is debugging in the Terraform. So Terraform has detailed log which can be enabled by set the environment variable called tf underscore log, right? With the help of this variable, you can set the Terraform log level. You can define these values to this environment variable like trace, debug, info, warn, and error. By default, the value of this tf log is equals to trace. Trace is the most verbose and it is default if tf log is set to something other than log level name, right? So if you're not defining the tf log to debug, info, warn, and error, then tf log is default set to the trace. To persist log output, you can set tf log path in order to force log to always be append at a specific file when logging is enabled. So whenever you want to make the Terraform log at a specific location, you want to save the Terraform log at a specific location for the debugging purpose or for the tracing purpose or for the archiving purpose, you can define the another environment variable called tf underscore log underscore path. So with the help of the environment variable tf underscore log, you can set the log level. That could be the trace, debug, info, warn, and error, right? And with the help of the tf underscore log underscore path, you can define the path of the file where the Terraform log will be saved whenever you will execute the Terraform configuration files. So this is the simple command export tf underscore log equals to the value. You need to export the environment variable on the machine where you are executing the Terraform. To disable, either unset or set it empty. If you want to disable the Terraform log, you can either export the tf log equals to empty, or you can simply unset the environment variable called tf underscore log. Whenever you want to set the tf or Terraform log path, you can export another environment variable called tf underscore log underscore path. Over here, we are exporting the path to dot slash terraform dot log. It means in the current directory and file name will be terraform dot log. So this is the way how you can work with the Terraform logs. So thank you team. See you in the next lecture. Hello team, welcome to Terraform training, and today we will discuss another section of Terraform certification, interact with Terraform modules. So this is section 5 of the Terraform certification course, and this is about the interact with the Terraform modules. In this course, we have already discussed and created Terraform modules in very details. So I'm just going to cover up the parts which we missed in the earlier labs or in the earlier modules. The part of this module is like contrast module source options. interact with the module's input and outputs, describe variable scope within the modules, and discover module from the public Terraform module registry. And in last, defining module versions. Let's start with the first option, contrast module source options. So module are used to organize the configuration in Terraform. In the earlier section of this course, we have discussed the modules in details, and the gist was we can use the modules for the code reusability. So the similar statement is mentioned over here. Modules are used to organize the configuration in Terraform. Modules make it easier to navigate, understand, and update your configuration by keeping related part of your configuration together. Another benefit of using the module is to encapsulate the configuration into distinct logical component. That is very essential. If you remember, then in our earlier labs, we have created the separate module for the VPC, for the instance group, and for the RDS services. Code reusability is the sole feature of the module in Terraform. So module help us in the code reusability. We can create the single module, and argument to that module can be passed with the help of the variable. We have seen all these things in the earlier lectures, and we have seen multiple labs on the modules in Terraform. Interact with the module inputs and outputs. So here is the pattern which defines the input for the module. So we can define variable like VPC underscore name, description, style, and default value, right? Over here you can see we have the default value like example.vpc. Whenever we are calling the module from some file, the configuration file, if we are not passing this variable VPC underscore name, then this module will keep the default value example hyphen VPC as a value of this variable. But if we are explicitly passing some other value to this variable VPC underscore name, then default value will not be picked by the module, and module will get the value which we are passing explicitly to this variable. Module also have the output which are defined within the module with the output keyword. So within the module, if you want to put some output which will be used by the source which is calling your module, then you can define the output like output VPC public subnet. Then you can define the output with the output keyword. Over here we are defining the public subnet IDs as a output, right? So we will keep it output VPC public subnets, the name of the output. Description is optional. If you want, you can keep it, otherwise you can leave it. Then we need to define the value. Value equals to module dot the name of your module dot the dot the name of your resource, right? Over here my resource should be public underscore subnets, which values I am putting in the output. Let's describe the variable scope in modules. So input variables serve as a parameter for the Terraform module. Allow aspect of module to be customized without alerting the module's own source, and allowing module to be shared between different configuration. As I told you earlier that whenever we are defining the default value for the variable which is the input variable for the module, if that variable is not explicitly being passed from the source file which is calling the module, then the default value will be passed. But if the source file that is calling the module, if that will define the input variable explicitly, then the explicit value which is being defined by the source file which will be passed to the module as a input. We have few modules like root module. Every Terraform configuration has at least one module known as its root module, and we have the another module child module. So a Terraform module can call another modules to include their resources into the configuration. A module that has been called by the another module is often referred as a child module. So if we have two modules A and B is calling A, then A is the child module of B, right? So that's all about this section. I am pretty much sure that you have already learned the modules in detailed way, so I don't need to explain each and everything in very details over here. Thank you team. See you in the next lecture.
Hello team, welcome to Terraform training, and today we will discuss about navigate Terraform workflow. This is section 6 in Terraform certification. In section 6, we are going to discuss about navigate Terraform workflow, which have the below topics. Describe Terraform workflow, initialize the Terraform working directory, validate a Terraform configuration, generate and review an execution plan for Terraform, execute changes to infrastructure with Terraform, and destroy Terraform managed infrastructure. These 6 topics are part of this section Navigate Terraform workflow, and we will discuss each and every topic in detail. Let's start with the first one, describe Terraform workflow. So Terraform workflow have the 3 steps. Although we have executed the Terraform commands or Terraform workflow multiple times in this training, but I'm still explaining all these steps so that we will get the clarity on it. First step of the Terraform workflow is write. The second step is plan, and third step is apply. So we have written the Terraform configuration file multiple times. We have seen the Terraform plan in almost each lab in this course, and every time after the plan we have executed the Terraform apply. These are the 3 steps which are the part of Terraform workflow. Write means write Terraform configuration just like you write the code. We have seen that we have write down the configuration multiple times. We have handwritten configuration which we use to provision the resources on AWS cloud. Terraform plan means preview the changes before applying. It means if you are just going to apply the fresh configuration, then you can execute the Terraform plan to see what are the resources which are going to be deployed with the help of the Terraform. But if you are making some changes in the existing configuration, then you can again execute the Terraform apply to identify that which changes are going to be made in the existing infrastructure. And Terraform apply simply provision the reproducible infrastructure. It means it will simply execute the Terraform configuration and it will do the job which is the part of Terraform configuration. So this is about the Terraform workflow which have write, plan and apply, and we are well aware the Terraform workflow. Initialize a Terraform workflow directory. We have done that particular thing as well multiple times. Every time whenever we have created a new directory in the Terraform, we have executed a command terraform init. That is the Terraform initialization. Terraform init command is used to initialize a working directory containing Terraform configuration file. As I told you in the training as well, whenever you are creating a new Terraform directory and you have the Terraform configuration in that directory, it is required to initialize the Terraform in that directory so that Terraform will get the prerequisite which is required before the Terraform execution. Terraform initialization or Terraform init is the first command that should be run after writing a new Terraform configuration or cloning an existing configuration file. Why this is the first command? Because it will set up the prerequisite. And what are these prerequisites? Terraform init will initialize the backend. It means it will initialize the Terraform backend service. Initialization search for module in configuration file and install the child module. Terraform init will also search the module which you have used in your Terraform configuration file and it will install the child module. It means it will install the used module in the Terraform backend, right? If you remember, then whenever we have started working with the modules, we have seen multiple times of the module, and every time we have executed the Terraform init, it have checked the Terraform configuration first, and if there is any module, it have downloaded the module, right? We have used the module from the Terraform registry, and we have seen that Terraform first download the module from the Terraform registry, and then it will download the Terraform plugin. Download the plugin is the last option. So Terraform will identify the provisioner you are using, and as per the provisioner, Terraform will download the plugin which is required to execute the Terraform resources or Terraform further commands or Terraform workflow. So Terraform initialization is required whenever we are creating a new Terraform directory which have Terraform configuration file, or whenever we are cloning the existing Terraform directory. Without initializing of the Terraform, you cannot execute any Terraform workflow in your Terraform directory. Validate the Terraform configuration. Whenever we have seen that we have created the Terraform configuration multiple times, what are those steps by which we can validate the Terraform configuration? Well, here the validation means we are not validating the actual functional flow of the Terraform. We are validating the syntax error in the Terraform configuration. That the configuration we have written down, the syntax of that configuration is fine, or there is some changes required in the configuration syntax. You can validate the syntax with the help of a command terraform validate. Terraform validate command validate the configuration file in the directory. Whenever you will go in any Terraform directory, right, and you will execute the Terraform validation, it will validate all the files present in that particular directory. It means all the Terraform configuration file present in that directory, Terraform validate will validate these files. Validate checks that verify whether a configuration is syntactically valid and internally consistent. As I told you, that Terraform validation will not validate your functional flow, that will just validate the syntax of your Terraform configuration files. If you want to print the validation result, or you want to store the validation result in some machine readable format, you can use the Terraform validate -json, right? This will provide the Terraform validation result in the JSON format, and that JSON can be used further in your workflow. So what is the production use case or the actual use case of this kind of format? So whenever we are working on the big projects, then definitely we are not going to execute this command manually on the box. We will set up some automation. It may possible that could be the Jenkins job, or that could be the script, right? So what you will do before executing any Terraform apply or Terraform plan, what you will do, you want to verify that the Terraform configuration which we are getting, is that valid or not, right? With the help of the Terraform validation.json, you can validate the configuration. It will produce a file. You can read that file, and if there is any kind of error in that file, right, that file is not intended as you are expecting, then simply you can halt your execution, right? You can halt your Terraform execution. You can halt your Terraform further execution. That could be the plan or apply or anything, whatever you want. Machine can execute that command, machine can create the output, and again machine can read that output to validate the further step. No human intervention required in that process. Next is generate and review an execution plan for Terraform. We have seen the Terraform plan multiple times. What we can discuss around it. So Terraform plan command is used to create an execution plan. Whenever we are executing the Terraform plan command will identify that what are the resources are present in the Terraform configuration, and it will create a chart of the resources. It will show you the resources which is going to deploy on the infrastructure, the attributes which those resources are using, that could be the network, that could be the image, that could be the security group, or any attribute which is required in that resource. It will display all that attributes as well. It will also show you the total number or the count of the resources which is going to be deployed whenever you will execute the Terraform apply after the Terraform plan. The Terraform plan command is a convenient way to check whether the execution plan for a set of changes matches your expectation without making any change to the real resource or the state. Definitely, that is a good point. Whenever we are performing the changes in the Terraform configuration, and if you want to verify that what change that configuration is going to push on my infrastructure, if you just want to verify these changes, you can execute the Terraform plan. Terraform plan will show you the complete blueprint that Terraform apply is going to apply on the resources. And if there is any kind of error, there is any kind of mistake, you can modify your configuration and again execute the Terraform plan. So with the help of this command, we are not going to directly jump in the production or jump in the infrastructure and changing the value. No. First, we are validating what changes we are going to push, and then we are going to push these changes on the infrastructure. We can also store the output of the Terraform plan with the help of the out argument. This is an optional argument, but you can mention the Terraform plan -out that can use to save the generated plan to a file later execution with the Terraform apply. So you can do this kind of thing. You can generate the multiple Terraform plan files, right? And you can execute a specific Terraform plan file with the Terraform apply command. You can execute a command like terraform apply, right? And you can provide the files like A, B, C, whatever you have created for the terraform plan. By this way, you can change your configuration, you can create the plan, and you can apply a specific plan. If you don't want to execute all these changes in a single go, you can go step by step as well. Execute the changes to the infrastructure with the Terraform, that is the Terraform apply. Terraform apply command is used to apply the changes required to reach the desired state. We have created the configuration, we have verified the configuration. Now what is the next action? We want to deploy these resources, or we want to make these configuration changes in my infrastructure, and that can be done with the help of the Terraform apply, right? Whenever we are executing the Terraform apply, it will apply the plan on the infrastructure. It will create the resources, delete the resources, whatever you are going to mention in the configuration, it will perform these changes on your infrastructure. The last is destroy Terraform managed infrastructure. How we can destroy the Terraform infrastructure? To destroy the Terraform infrastructure, the main file is the state file, and you can destroy the infrastructure with the command terraform destroy. You can simply execute the command terraform destroy, but this will ask for the confirmation. If you don't want to provide the confirmation explicitly, you can execute the command terraform destroy hyphen auto hyphen approve. This means that the destroy is already approved, and it will simply destroy all the resources which are the part of the Terraform configuration, or I must say which are the part of your Terraform state file, right? It will read the Terraform state file, whatever the resources mentioned in your state file, it will terminate these resources on the infrastructure. So this is about this section. If you have any doubt, any question, then you can ask me. Thank you, team. See you in the next lecture. Hello team, welcome to Terraform training, and today we will discuss about the another module of Terraform certification, implement and maintain the state file. So let's start. This is section 7 where we will learn about the implement and maintain state file from Terraform certification. So although we have already discussed Terraform state files in quite details, we have seen almost all of the aspects of the state file, but let's go through the content which is required for Terraform certification in this section. First is describe default local backend, outline state locking, handle backend authentication method, describe remote state, and describe effect of Terraform refresh on state. And next is understand secret management in state file. So team, these 6 topics are the component of implement and maintain state section 7. We will discuss these one by one. First, let's discuss about the describe default local backend. We have already discussed this term multiple times during this course. Backend in Terraform determines how state is loaded and how an operation such as apply is executed. So as I told you earlier as well, Terraform have the backend process. That backend process will maintain all the operations you are performing on the Terraform. And the same backend process will also maintain the state of state file in object. So backend is responsible for the loading of state file plus the operation which we are performing on the Terraform. By default, Terraform uses the local backend. When I'm saying local backend, it means whenever you are executing the Terraform in your local machine, you are initiating the Terraform and you are executing few Terraform commands, Terraform by default start a local backend on your machine. Backend can store their state remotely and protect the state with logs to prevent corruption. But if you don't want to use the local backend, there's an option of the remote backend as well. It means you can create the Terraform backend at a remote location. There could be the multiple benefit of creating the backend at the remote location, and the major benefit is the machine failure. It means suppose you are deploying your environment or your infrastructure with the help of the Terraform, and due to some reasons, if your machine got failed, right? Your local machine which you are using to create the environment with the help of the Terraform, if that got failed, or you will get some internet connection outage or power outage, then it will not stop the provisioning. Terraform will not stop the provisioning of the resources, because the process which Terraform initiated, that process is executing at the remote machine. So we can use the local backend, plus we can use the remote backend as well. State is retrieved from the backend on demand and only stored in the memory. The machine which is executing the Terraform, or the machine which is executing the Terraform backend, that machine can retrieve the Terraform state on demand and can store it in the memory on the same machine. User can successfully use Terraform without ever having to learn or use backends. If you don't want to learn backend, there's no requirement. You can use the Terraform, because that is a backend process, and user don't need to worry about the backend state or the backend object configuration, right? You can use the Terraform without even think about the backend in Terraform. The second topic is outline state locking. In the earlier lectures as well, we have discussed about it. We have discussed about the locking of the state file. Whenever multiple people are using the Terraform and they are using the same machine to provision their environment, then it may possible you will face the problem of the state file lock, right? So state file locking happens automatically on all the operations that could write state. It means if two peoples or three people are using the same machine, same remote machine, right, and they all are executing the operation which is writing something in the state file, in that case only a single person or a single user will be able to use the Terraform command which is writing in the state file, because Terraform will maintain the lock, a automatic lock on the state file whenever you are executing some commands which are writing in the Terraform state file. User can disable the state locking for most commands with the -lock command, right? If you want, you can disable the locking with this command. You can just need to provide the Terraform command, and after the Terraform command you can mention -lock, right? This will bypass the locking of the Terraform file, but this is not recommended. I really don't recommend this practice. This may interrupt your Terraform state file. Why this may interrupt your Terraform state file? Because default behavior of the Terraform is to lock the file whenever multiple operations are writing in the same file. But if you are using -lock, that it means that operation will not lock the file, and it may possible that two operations simultaneously may write in your Terraform state file, and that will corrupt your Terraform state file. User can also execute force unlock to unlock the state file. Definitely, if the Terraform file is in lock state since long and you want to unlock it, right, you can use the unlock option, force unlock on the Terraform state file, and you can then further execute your Terraform operation. But force unlock is also not recommended, because we don't know that which operation or which Terraform command is using or writing in the Terraform configuration file, so that the file is locked. The next topic is describe effect of Terraform refresh on the state. So in Terraform, we have a command Terraform refresh. We need to understand what is the effect of the Terraform refresh command on the Terraform state file, and in which case we can use the Terraform refresh command. So basically, Terraform refresh command is used to refresh the Terraform state file. So whenever you realize a need that we need to refresh the Terraform state file, you can use the Terraform refresh command. That will refresh your Terraform state file against the resources which are provisioned on the cloud environment. This file will not modify the infrastructure, but does modify the state file. So what does it mean? It means if you have done some modification on the infrastructure, right, you have explicitly changed some configuration of the resources on the cloud infrastructure, but that information is not in the sync with the Terraform. In that case, you can execute the Terraform refresh. That will not change anything on the infrastructure, because the infrastructure changes are done explicitly, right? But it will modify the state file as per the changes which is being done on the infrastructure. So if there is any change in the resource configuration or the resource ID, if you will execute the Terraform refresh, it will not do any change on the infrastructure, right? But it will do the change in the Terraform state file, so that your Terraform configuration will be in sync with the infrastructure. Next topic is about the sensitive data in a state file. We can keep the sensitive data in the state file, but the sensitive data in the state file will present in the plain text. That is the problem, right? Whenever you are keeping the sensitive data in the state file, that could be the password, your DB username, or anything which is sensitive for your business, right? You can keep that data in the Terraform state file, but that will write in the state file in the plain text. So what is the solution? So Terraform state can contain the sensitive data depending on the resource in use. It means what resources you are using to contain the Terraform state file. Is that the local state or is that the remote state? State in local machine is stored in plain text JSON file. Whenever you are using the local state, the all information which is present in the state file that will stored in the plain text in the JSON format. Storing the state remotely can provide the better security. How storing the state remotely can provide the better security? Because the data which is flowing from your local machine to the remote machine, because the data which is flowing from your local machine to the remote state, that will be encrypted by the cloud. So this is about the state file section. We don't have much information to discuss in this section because we have already learned a lot of things about the state file in the Terraform course. So thank you team. See you in the next lecture. Hello team, welcome to Terraform training, and today we will discuss another section of Terraform certification. And today we will discuss about the read, generate, modify Terraform configuration. This is section 8 of the Terraform certification, and section title is read, generate and modify configuration, and here are the subtitles of this section. Demonstrate use of variables and output variables, describe the secure secret injection best practices, understanding of use collection and structured data types, create and differentiate source and data configuration. These are the things, and we have covered almost all of the things which are listed over here. We have seen the input variables, we have also seen the output variables, input variables in module and output variables in module. We have seen the secure secret injection as well. We have seen the different kind of data types, the collection data type or the structured data type. We use the lookup functions, map, list. These are the data types which in the collection and structured, right? We have also choose the data configuration and the resource configuration in our labs. But still, let's refresh what we have done. First, we will start with the input variables and the output variables. In Terraform, user can create variable specific Terraform configuration file. If you remember, we was using the variable.tf, and that configuration file was only containing the variables, right? We can create the separate file to keep the variable at a single place, and we can use that variable file across the Terraform configuration file which are present in that directory. So it is a best practice to keep the all variables in a single file. If you want, you can create the variable file module wise as well. Here is the sample of the variable, how we can declare the variable. So you can see we are taking the keyword variable, then we are defining the variable name, and over here my variable name is region. Here I'm taking the default value as US West 2. So you can define the default value for your variables as well. Over here for my variable region, I'm defining the default value US West 2. So we have seen that earlier as well, that user can define the variable value as a default as well, or you can explicitly pass the value as well. So if you want to pass the variable value region value explicitly, then definitely we can pass that particular value explicitly as well. And in that case, whenever you are passing the variable value explicitly, it will not consider the default value. If you are not passing the variable value explicitly, then it will consider the default defined value. So over here you can see I'm defining a command terraform apply hyphen var, then I'm defining my variable region equals to us hyphen east hyphen 2. So suppose I have defined the region variable as defined over here, and the default value is us west 2. If I'm directly going and executing the terraform apply, then it will deploy the resources in US West 2 because I'm defining the region US West 2. But if I'm going to explicitly pass variable region and I'm defining the value US East 2 as I'm defining in my command, in that case the variable value region will be override by the
value which I'm passing by a command, right? It will not consider the default and it will take the variable value which I'm defining in a command. So this is the input variable, and we have seen these use cases multiple times whenever we was learning the modules. Within the module, we was taking the default value, but we were overriding these variable values by the explicit variable.tf file. Mention of the secrets in variable file are not recommended. I never recommend to mention the AWS secret key or the user key in the variables. If you remember, I have defined my AWS secret and access key as an environment variable on my box. I never used the credential in the variables. So it is not recommended to use the secret in the variable, right? Why it is not recommended? Because if you are mentioning your secret in the variable file, then first thing, that variable value will be plain text, right? And second thing, you are going to commit that file on the VCS system. It means version control system. Any but anybody or any user who have the access of that repository on your version control system, they can get your secret. And if they can get your secret, then that is a no more secret, and they can damage or harm your infrastructure using these values. So it is completely not recommended to use the secrets in the variable files. Then what is the way to manage the secret? So whatever the secrets you want to keep inside your Terraform, you can create a local file on your local box like secret.tfvares, right? And whenever you are using the Terraform apply, you can use a flag -var-file and pass that file to the Terraform apply, so that Terraform apply will also load that file. It will read the most of the variables from your VCS system, from your variable files, but it will read the secret from the defined secret tf-var files, right? By this way, you are keeping your secret up to you only, right? You are not going to share the secret on the version control system or inside the variables. You just create a simple file that will contain your secret, and you can use that file with the help of a flag -var-file, and it will act like a variable for the Terraform. If you have a multiple variables file, then Terraform provides the flexibility. You can use the multiple variable file with this argument var-file in a single command. So you can define a command like Terraform apply -var-file equals to file name, which could be your secret variable, which could be your product specific variable, which could be your infrastructure specific variable, which could be your environment specific variable. And if you want another variable file to use, you can use the same keyword again, -var-file equals to define the another variable file. So you can have up to n number of variable files, and you can use these variable files in the Terraform apply command with a flag -var-file. There is no limitation. So we have discussed about the input variables, the output variables we have already seen multiple times during the lab, right? So I'm not going to explain the output variable. Let's move to the next point, secure secret injection best practices. So in Terraform, we have the multiple way to manage the secrets, and few possible way are AWS Secret Manager, GCP Secret Manager, Azure Credentials, and HashiCorp Vault. So over here, I have listed 4 ways how you can manage secrets in your Terraform. So let's suppose you are working on some project that is a big project, and there could be the hundred or thousand of the secrets which you can't remember or which you can't keep inside a simple file which is present on your local box. And you want that I am not going to commit the secret in the Terraform as well. So how can I use the secret in my Terraform? You can use the secret managers, right? AWS also have the secret manager, GCP also have the secret manager, and public cloud Microsoft Azure also have the credential manager, right? These are the third party secret manager which you can use. Inside the secret manager, you can define the key value pair. The key will be your secret key and the value will be your secret value, so that you can use the variable name in the secret key and the value will be the secrets value. And at the time of Terraform apply, you can directly read these credentials from the secret managers. The another way, which is the Terraform way, that is the HashiCorp Vault. Vault is another service like Terraform which is provided by the HashiCorp, and Vault is created to keep the secrets inside the Terraform only. If you don't want to keep your secret in some public cloud, right, you can use the internal HashiCorp service Vault. Vault is a web server. Whenever you are going to install the HashiCorp, you also need to install the Vault. Once you will install the Vault will be accessible on a port 8200, and once you will hit the IP on port 8200, you will get the Vault UI. And inside the Vault UI, you can define your secrets, and you can use the Vault as a resource in your Terraform configuration and read your credential directly from the Vault, right? It must be on the same machine. Mention the secrets in Terraform config, state file and environment variable are not recommended. I have already discussed it multiple times that mentioning your secrets inside the config file or the state file is not recommended, but it was using the environment variable to keep the secret. But today we have discussed that there could be the multiple ways to manage these secrets. So definitely the environment variable is again not a recommended way. Let's understand the use of collection and structural data types in Terraform. So collection type allow multiple values of one other type to be grouped together as a single value. If you are familiar with any programming languages like Java, Python, Ruby, C Sharp, then every programming language have the collection data type. Similarly, the HashiCorp Terraform have the collection data type, and Terraform have the three collection type: list, map, and set. List is a sequence of the values, and you can keep the similar kind of values in a list, right? The sequence will be the 1 2 3 4 5 a b c d, or it could be the sequence of the names or anything. The map is the collection of the key value pair, right? Here you need to define the key and the value, then key then value, then key then value. In the map, the key or the value cannot be null. The set is a collection of the unique values. In the list, you can keep the duplicate records, but in the set, you cannot keep the duplicate records. So these are the collection data type. If you are going with the structural data type, then structural data type allows multiple values of several distinct types to be grouped together in a single value. It means you can group multiple data types at a single value. You can keep the integer string at a single data type. That could be the structured data type. And Terraform have the two structural data type. First is the object, right? A pair of curly braces containing the comma separated series of the key and value type. So over here in the example, you can see we have the name John and age 52. The name John is a string type, but age 52 is an integer type. And second, we have the tuple, right? A pair of the square bracket containing a comma separated series. So you can see in the object we have the curly braces, but inside the tuple we have the square bracket. And here the first value is a, second is 15, then third is true. A is a character over here, 15 is an integer over here, and true is a boolean over here. So over here you can see we are grouping the three data types into a single tuple. So these kind of data structure called the structural data type in Terraform. So that's all about this lecture. If you have any doubt, any question, you can ask me. Thank you, team. See you in the next lecture. Hello, team. Welcome to Terraform training. And today we will discuss about the Terraform cloud. This is the last section of the Terraform certification. And here we will discuss about the Terraform cloud, which is completely a new topic for us because we have not discussed about the Terraform cloud before this. This is section 9, where we will understand the Terraform cloud and enterprise capabilities. The topic of this section is describe and benefit of Sentinel, registry and workspace, differentiate OSS and TFE workspace, summarize the features of the Terraform cloud. So first, let's discuss about the Sentinel. What is Sentinel in Terraform? Sentinel is an embedded policy as a code framework integrated with the HashiCorp enterprise product. Till now, we have not discussed the policy. Inside the Terraform, we are creating the configuration, we are creating the infrastructure as a code. But here we are reading a new term, policy as a code. So Sentinel is a framework where you can code your policy, right? And then you can apply that policy on your product. That could be the HashiCorp Terraform, or that could be the HashiCorp Vault. So first, we need to understand what is the policy. So policy is a statement of intent and implement as a procedure or a protocol. in the old era or even in the present time as well, whenever we are talking about some policy, that is a Word document where we found some instructions, some procedures, right? And we need to accept these policy. But here in the Sentinel, the policy is a code, right? We can create the code of my policy. So what could be the policies? The policies could be the security policies adopted internally, protected data privacy and infrastructure integrity. Suppose we want to create a policy that only these kind of security group will be able to access my database services. We want to apply some policy like that none of the resource or none of the security group will have the 0.0.0.0 all users access. We want to apply some policy that I don't want to execute any resource out of US West 2 in the production, right? Or any resource from EU West 1 in the staging environment. So these could be the policies or these could be the rules which you can code in the Sentinel. You can have the operational policies as well which will prevent the service outage or the degradation. We can create a policy that minimum this number of the servers must be running for this service all the time. So that will call the operational policies which will prevent the service failure or the service outage. Creating policy as a code require a way to specify policies and mechanism to enforce them, right? Whenever we are talking about the policy as a code, first we need to specify the policy, first we need to code the policy, and then we need to apply a mechanism, we need to create a mechanism which will enforce that policy on the resources. Sentinel is the solution for that kind of problem. Sentinel provide a simple policy oriented language to write the policies and integrate with our tools like Terraform and enforce them on the Terraform resources or the cloud resources. Here I am sharing the sample policy. That policy requires the VPC to have DNS or host name enabled. And here is the policy. So this policy will use the Sentinel TF plan version 2, right? And require all the VPC support DNS and EC2 instance created in them will have the public DNS if they have the public IPs. So first we need to import the TF plan functions, and we are taking the TF plan functions alias as a plan, right? If you don't want to import the TF plan functions, you can simply import the TF plan as well. TF plan is the wrapper class of all the policies which you can create in the Sentinel, and then we will get all the VPCs. So we are getting all VPC is equal to plan. Plan is the alias of the TF plan functions. Then we are using a function find resources, and we are defining the resource name AWS underscore VPC. This will be your resource name. Then we are filtering out the VPC for the violation. So violating the support VPCs, which are violating the support VPCs, and second one is which is violating the host name. So first one is the plan filter attribute is not a value, and we are passing two argument, and we are passing few argument to these functions. All VPCs which we have retrieved enable DNS support which we want to support. Then we are putting true and true. It means all VPCs must have this value true, right? Similarly, for the host name, we are taking the enable DNS host names. That value must be true. And then we are enforcing these policies using the main rule. You can see over here, we are putting validate equals to length violating support VPC message equals to 0, and length of violating hostname VPC message equals to 0, right? Then we are calling the main function, and inside the main function, we are calling a rule and calling the validated statement. Any of these statement, the first statement mentioned in the validated or the second statement mentioned in the validated will be false, or both of the false, this policy will not be enforced on the resources and your configuration will be failed, right? So this is the benefit of the Sentinel. You can create your own policy and you can enforce these policies on the resources. Now the second one is the module registry. So we have discussed about the So we have seen the module registry multiple times in this course. We have seen the module registry in the lab. That registry is the registry.terraform.io, right? And we have used the multiple modules from the registry as well. We have used the EC2 module, we have used the VPS module and the RDS module. So Terraform Cloud provide the private module registry or also provide the public module registry. Private module registry can be specific for the organization, and only that organization can access those resources or those modules which are whitelisted in the private module registry. If you want to use the public module registry, you can use it because public module registry have the multiple modules from the multiple organizations, and organizations have published them. You can use them as per your own convenience, as per your own use. The modules, the benefit of the module registry is the modules in the registry can be versioned, right? And they can be searched easily. You can search any of the modules. Suppose you are going to search for the AWS VPC module, you will get a list of the modules because multiple organizations are providing these modules. Even apart from the AWS, there could be the hundred of the organization which are providing these module, and each module organization have some additional feature. You can choose the module as per your requirement, or you can take them module, do some modification and create your own module as per your need. The last is the benefit of the workspace. We have discussed about the workspace multiple times. Like we have the workspace in any code editor tool, similarly we have the workspace in the Terraform. Workspace is something where Terraform cloud organize the infrastructure. You can create the multiple workspace for different environments. So working with Terraform involve managing the collection of the infrastructure resources. Definitely a single Terraform configuration is the collection of the infrastructure resources, and the best way to manage these collection of the resources is the workspace. Terraform Cloud manage infrastructure collection with the workspace instead of the directories. Whenever we are going with the Terraform Cloud, then in the local machine we have created the Terraform directory, but Terraform Cloud will create the Terraform workspace. It will not manage the Terraform by Terraform directory. Each workspace in the Terraform cloud retain the backups of the previous state files, right? So you will have the current state file, but you will also have the backup of the previous state file in the workspace, like we have the backup of the state file in the local Terraform as well. Terraform Cloud manage the workspace Terraform runs, and it retain the record of all activities, right? How many run you have provided for the Terraform in a workspace, Terraform Cloud will contain the record of each and every run which you will perform in a Terraform Cloud. It will keep all the records and all the activities, all the logs which is being done as a part of that run. So let's summarize the feature of the Terraform Cloud. Terraform Cloud is an application that helps team to use Terraform together. So in the local box, you are installing the Terraform, you are doing your work, but Terraform Cloud is the cloud solution for the Terraform, where you need to sign in your Terraform Cloud. You can create a configuration and you can execute your configuration. All the administrative work will be done by the Terraform. In that case, even if you are going to log out from Terraform Cloud will still create the resources until unless the Terraform run is executing. Terraform Cloud manage the Terraform runs in a consistent and reliable environment. Definitely in your local machine, there could be the multiple kind of failures and your machine may be crashed during the resource creation. But if you are using the Terraform Cloud, then there is no fear because the administration job is the part of Terraform. So Terraform will on manage the execution. Terraform Cloud is available at a hosted service at app.terraform.io. You can go to this URL and you can create your own Terraform account and you can hands-on your Terraform account. Terraform offers free account for the small teams. If you're an individual person, you can use the Terraform Cloud and you can create a free account on the Terraform Cloud. If you are a small company, right, you can go with some paid plans which will have some additional features. But if you are a very big company, you can go with the large enterprise solution which is called Terraform Enterprise. So that's all about this section. If you have any doubt, any question regarding the Terraform certification, you can ask me. In the coming lectures, we will post some questions on the Terraform certification. Please go through these questions. These questions will help you to get the more clarity on the Terraform certification material, and it will help you to clear out the Terraform certification in first attempt. So thank you team. Best of luck.